Hey, what's up everybody? Welcome to the third episode of How to Avalanche at Home. First of all, I'd like to extend my thanks to everybody who watched the first and second videos, everybody who's left either a like or left a comment, and most importantly, I've definitely heard you. A lot of you have asked me about non-technical aspects of what Avalanche is, why it's interesting, etc. So I'm going to take this episode to actually talk about the non-technical aspects of Avalanche. So the purpose of this video is to share the knowledge that I've been able to pick up over the last couple of years just by looking at what the Avalanche team is doing. I'll talk a little bit about the history of blockchains that came before Avalanche. Then I will talk a little bit about Avalanche and how it tackled some of the problems that we've seen with the previous blockchains. I will talk a little bit about the ecosystem that's growing around Avalanche as a whole. I'll even give you a mathematical reason as to why you should always stake or delegate if you own any Avalanche coins. And overall, I'm going to try to answer a lot of the questions that I've received at the back of the first couple episodes that we've shot. Now, before I go any further, I'd like to point this out as well. This video is not intended as investment advice. I hear a lot of questions about where's the price going, when is it going to go to the moon, when is it going to do whatever. I have no idea. I am no expert in that regard, and I'm simply looking at it from the technology perspective and the value that it brings to the table perspective. My goal is to share some of the insights that I've been able to get by having discussions with the team, having discussions with the community, and that's the intention of the video. If you're looking for investment advice or if you're looking to invest into this technology, this is not the right video. And if you want to invest, please make sure to do your own due diligence before making any decisions. As always, please go ahead and leave any questions or any feedback that you may have down in the comments below. Otherwise, if you like the video, please go ahead and like it. And if you'd like to see more of these videos in the future, go ahead and subscribe to the channel. Now, there will be a bunch of topics as a part of this video that I'll be providing my opinions on. If you see anything wrong or if you don't agree with anything that I'm saying, I particularly, relating to the Bitcoin and Ethereum type stuff, I feel like I'm going to get slaughtered. I don't mind. Go ahead and leave that commentary at the bottom so that, we can engage in discussions. All right, so let's start with the brief history of the blockchain technologies that came before Avalanche. The obvious place to start is Bitcoin. So what is Bitcoin? Bitcoin is a value transfer mechanism very much like money. I know that a lot of people call it magic internet money, etc. But if you actually dig deep and look at what it is, it's very much like money. The big difference is it's a mechanism for paying for goods and services which does not rely on any intermediaries in the middle. In simple words, it's a mechanism where if you sell me something, I can directly pay you without needing the Visas, the MasterCards, or the banks in the middle. So how does Bitcoin work? Basically, when I send some Bitcoins from my wallet to somebody else's wallet, the software under the covers creates a transaction and broadcasts that transaction to the network. The people that operate the network, that we call miners, notice that transaction. They do some computation to confirm the validity of that transaction. And once that validity level is achieved, they record it into the database that each of these miners are keeping track of. Once every single miner within the network records the action that me sending some Bitcoins to somebody else into their database, at that point, anybody looking at the blockchain will notice that those Bitcoins no longer belong to me and they actually belong to the person that I've sent to. At a very high and non-technical level, this is how Bitcoin works. So let's talk a little bit about these miners. Who are they? Why are they doing, etc. So as I mentioned earlier, miners are the people that are operating the Bitcoin software to continuously validate these transactions of people sending each other Bitcoins, right? You may be asking yourself, why does anybody care about this and why would they do it? The reason is the software that Bitcoin incentivizes these miners to continuously do this operation through two mechanisms. The first mechanism is every time you validate a transaction and you are the first person to validate that transaction in a very high level, simplistic sense, the software actually rewards you with a certain number of Bitcoins. This is the first incentive. The second incentive is the person sending that transaction pays a certain transaction fee, and these transaction fees also directly go to the miners themselves as well. Now, the first incentive, which is the newly minted Bitcoins, will eventually run out because there will only be a certain finite number of Bitcoin in existence. I'll talk a little bit about this when I come to the economics section, but that incentive is expected to go away, and eventually miners will only be earning the transaction fees within the system. The second question that people typically ask me also is, how does it ensure that people are continuously mining, particularly if the first reward goes away? The mechanism, again, I'm going to be very high level, the mechanism that Bitcoin uses to achieve this is through competition, basically. Bitcoin has a winner-take-all mechanism where the first miner who validates the transaction correctly ahead of everybody else is the one that actually receives the first reward that I mentioned, which is the minted Bitcoins. As you know, Bitcoins are quite valuable today, and the competitiveness among the miners is what drives a lot of these miners continuously operating and continuing to compete with each other. All right, let's talk a little bit about the economics of Bitcoin as well. I get this question a lot as well. What is backing Bitcoin, right? This is the question everybody asks. People always think about gold backing the dollar, etc. I don't really know if that's true anymore. I'm no expert, but there is nothing backing Bitcoin beyond the belief that people believe it to be valuable. Does that make sense? Money is only valuable as long as people believe that they can take their money, go to the store or go to wherever goods and services are being, exchanged, and give their money away in return for something, right? Bitcoin is very similar. Whether it's the speculators that continue to buy it or whether it's the people that are actually using Bitcoin to purchase goods and services, that's the backing that keeps Bitcoin's value intact, right? So there is no physical asset that's backing Bitcoins. In terms of the economics, the interesting thing about Bitcoin is that the software itself actually limited the total number of Bitcoins that can ever exist. As most of you may know, this number is set to be 21 million. And as miners continue to validate transactions that are going through the system, we will eventually reach that 21 million Bitcoins number. Now, another question that I get is, okay, if there's only 21 million, how can I use it or how can I even acquire it to actually go buy stuff, right? Again, because Bitcoin is ultimately a mathematical and software type product, each Bitcoin is divisible into very small fractions as well. So it's not like, if you want to go buy bread over time, if Bitcoin becomes a big thing, you want to go buy bread, you don't have to take a full Bitcoin. You can take a fraction of a Bitcoin that is, applicable to buy bread from the store, right? So ultimately, that's how the economics works. The interesting and the big difference in terms of monetary systems is that a central entity cannot come in and increase the total number of supply, which is the big principle that a lot of crypto enthusiasts always talk about. This finite set number creates what we call scarcity, and effectively, as people need more Bitcoins, the expectation is that the value of Bitcoin should increase. Obviously, the jury is out on that, but today, as of this video, Bitcoin is about $16,000 or so. And, we'll see how that goes from this point on. All right, next up, let's talk a little bit about cryptocurrency wallets. In this context, Bitcoin wallets, what are they? You can think of a wallet as a bank account that you yourself maintain rather than a central banking institution. The way it works is you get a numerical address that actually is visible on the blockchain, and you have a key that goes with that address, which allows you to unlock that address and send transactions from that wallet or address effectively. If you want to send somebody money or if you want to send somebody a message that's signed by that numerical address, you need to use the private key. And as I mentioned earlier, transactions that are broadcasted, once they're validated, they are irreversible. So that's why you always hear that you have to keep your private key safe and you should never share it with anybody else. All right, let's talk a little bit about some of the drawbacks of Bitcoin as well. Even though Bitcoin, when it came out, was a complete breakthrough in terms of peer-to-peer payments, in terms of decentralization, over the last 10 years, the community, the users, etc., identified, a good number of drawbacks. I'm not going to cover all of them. This is a controversial topic. I'm only going to touch upon the ones that I believe are important in the context of discussing Avalanche later. So first and foremost, Bitcoin, as it stands today, is slow. There have been some variants of Bitcoin that came out over the years, but the big one by liquidity still suffers from the speed problem, where the number of transactions that the system can process is simply not enough to sustain the entire world's monetary transactional needs. If we envision a system that over time actually becomes the monetary system where people use it to send money to each other, Bitcoin just cannot be the end game. The second problem that I see with Bitcoin is it's just not energy efficient. So the miners are actually continuously solving computationally difficult puzzles to perform validations and record transactions into their databases. This act continuously gets more difficult as new puzzles are solved, and the existing mining entities need to continuously invest into better hardware and more electricity, more energy to continue operating their mining pools. Again, this is not an ideal scenario because it makes mining a very capital-intensive operation. And if I wanted to become a miner myself, I need to invest millions of dollars into mining equipment, which means that, the act of mining itself is also not inclusive. Again, this is a big barrier for people like myself and yourself to actually enter into the mining operation. And this also leads to less decentralization than ideal. If you look at BTC.com right now at the time of this video, you'll see that 12 pools roughly control 97% of all validation and, as I said, operational activity of the network, which is very significant. If we're talking about true decentralization, that number should be in the thousands, maybe in the tens of thousands, right? And unfortunately, due to the difficulty of becoming a miner, the mining pools have consolidated over time, particularly the ones that started mining early, earned their rewards early, so they were able to invest into bigger and better hardware, into data centers, etc., which led Bitcoin to, a more centralized state than ideal. Last but not least, one of the issues with the existing Bitcoin network is that it's susceptible to attacks. It's susceptible to issues such as selfish mining, which I'm not going to cover as a part of this video, but it was identified by Gün Sirer, who is one of the founders of Avalanche. And if you actually Google it, you're going to see that doing bad things is quite possible with less than 50% of the hash rate in Bitcoin, which again is not a good scenario. This is all I'm going to talk about in terms of drawbacks. If you disagree with me, if you think there is more or less, please feel free to put them in the comments, and I'll be looking forward to reading them as well. All right, so that's all I'm going to cover for Bitcoin. Please, if you think I got something wrong, if you disagree with me, or if you know of other issues that you think are important, leave them in the comments. I'd like to see all of them, and I will respond to all of them as well. All right, let's talk about Ethereum now, which I believe represents the beginning of the second generation of blockchains. Now, in a simplistic sense, the Ethereum native token Ether has the same exact characteristics as Bitcoin, i.e. you can use it to send it to people and you can use it to pay people. But Ethereum adds a very large breakthrough since Bitcoin by creating the ability to write software which allows people to transact with each other without having to trust each other. Typically, the way I explain this is through a practical example, and I'm going to sort of try to do the same here. Think of your home, right? If you could represent your home as a digital ownership certificate and you wanted to sell it, anybody who has digital money to pay you could come. You can write software which represents a digital box, which allows you to put your certificate in it, which allows people to put their digital money in it, and the software can look out for each of these things coming into the box, and when they both arrive in the box, do the swap. This box that I'm describing in a very simplistic sense is what people call a smart contract. You can basically write software that performs, certain operations in a completely trustless manner and deploy it onto the blockchain itself. In contrast, when you think about what happens now is for you to sell your home, you need a broker, the buyer needs a broker, you need a title company, you need a lawyer, the other side needs a lawyer, and every single one of these middle people or middle entities, if you will, represent a piece of trust that you need to be able to perform that transaction. All right, so let's talk about some of the improvements that Ethereum brought over Bitcoin beyond the smart contract capability. So Ethereum has less winner-takes-all mechanics within it, which means the miners that first solve the puzzle do get rewarded, but also people that solve it second, etc., also get rewarded. Now, this makes it a little bit better, but it doesn't make it a whole lot better. The other thing that Ethereum tried to do is the software implementation tried to prevent application-specific integrated circuits for mining so that people who have standard off-the-shelf hardware can actually participate in the network. But again, the level of success in this regard is also arguable. Ethereum is faster than Bitcoin. It can process more transactions per second than Bitcoin, but unfortunately, as it stands today, it still cannot perform all of the transactional needs in terms of money of the world with the number of transactions that Ethereum can process. I think the biggest and most important improvement Ethereum has over the previous generation is the fact that the people behind Ethereum, the community, the developers, etc., have a long-term plan to continue improving Ethereum and to actually solve the key challenges that I've described as a part of the Bitcoin section. Now, they have a plan, they have a roadmap around this. It remains to be seen if Ethereum is going to be successful in achieving these goals, but at least they are trying to solve some of these issues. All right, let's briefly touch on the drawbacks of Ethereum as well. The major drawbacks are similar to Bitcoin, honestly. The one that's actually different than Bitcoin is the fact that Ethereum, in terms of economics, does not have a supply cap. This means Ethereum tokens can be continuously minted, which will have implications to the value of the actual Ethereum tokens. It remains to be seen if it will lead, Ether tokens to go to a value of 0. I don't think that's going to happen. As you know, Ether tokens are still valuable today, but that's one big difference. Now, the other drawbacks are very similar to Bitcoin, like I said. Ethereum, although it's slightly faster, it's not fast enough to provide the entire transactional needs of the world. Winner-takes-all economics is slightly improved, where not just the first person solving the puzzle gets the reward, but also additional people can get it. The other issue that Ethereum and Bitcoin suffers from is if there is a big demand of transactions within the network, because being a miner is expensive, that leads to transaction fees shooting up. Basically, you have a limited number of miners, and if there is a lot of transactions that need to go through, the transaction fees basically climb, which means that in certain cases, if you want to send money, the amount of transaction fee you may end up paying may actually be more than the amount of money that you're trying to send, which obviously is not ideal. All right, that's all I have for Ethereum in the video. I'm actually going to be compiling a list of videos that I personally found interesting and leaving them in the information section of this video. I'm going to do the same for the Bitcoin discussion as well. Otherwise, if you think you disagree with me in some aspect or you have something to add to the conversation, by all means, please put them in the comments so that I can see them, I can respond to them, or at least I can read them. All right, let's talk about Avalanche. So Avalanche is designed to be the main blockchain, the main solution for decentralized finance. In fact, if you actually look at the Avalabs webpage and look at their vision statements, you will see that they want to position Avalanche as the base layer for all other blockchains and all other cryptocurrencies. In other words, and simply said, this means that other blockchains out there who still suffer from some of the key challenges from the first and second generation of blockchains can actually pick up Avalanche as their base layer and immediately benefit from some of the key breakthroughs that it actually brings to the table. Now, the discussion points are multifold and the improvements are quite impressive, so I'm going to discuss them in distinct sections from this point on. All right, let's first talk about the utility and the economic balance within the Avalanche system. So the native token AVAX can perform the exact same utility as Bitcoin as well as the native Ethereum token Ether. You can basically use it to send it to people, and eventually if it gets adopted, you can use it to pay people. The interesting aspect on the economic side is the fact that the supply of the tokens is actually designed to be in balance between inflationary and deflationary pressures. Let me explain what I mean by that. So if you or any other validator joins the network, for their validation work, they actually get rewarded by a certain percentage of the AVAX tokens they actually hold, okay? Basically, this means that when you join the network and you validate transactions for a period, you're going to get a certain percentage of the tokens that you staked on that node. This creates the inflationary pressure where once your staking period is over, the system mints new AVAX tokens and deposits them into your address, increasing the circulating supply. The deflationary pressure comes from the transaction fees. Unlike Ethereum and Bitcoin, where transaction fees are directly paid to the miners, in the Avalanche system, transaction fees actually get burned. This means that if anybody performs a transaction, this is valuable to everybody else that holds AVAX tokens because transaction fees get burned, they get removed from circulation, increasing the scarcity of existing AVAX tokens in circulation. The intention here is that eventually the amount of transaction fees being burned is going to sustain the amount of AVAX tokens being minted for the validators, making the system in sort of a balance, which I actually find very interesting. Now, the additional side effect of this kind of a system is the fact that transaction fees are static. So unlike Ethereum, unlike Bitcoin, where transaction fees will fluctuate, the amount of transaction fee that me have to pay can be set in a static manner for when we're sending money to pay for goods and services. Obviously, the smart contract side is a little bit different, but I find this very interesting. And this also means that during highly utilized times of the network, I still don't have to pay additional transaction, fees to get my transaction across. Obviously, Avalanche supports smart contracts through its C-Chain. And the very interesting thing about Avalanche actually is that it's directly compatible with existing Ethereum tooling. You can create smart contracts using Solidity. You can directly deploy them onto C-Chain. And if you already have an application on Ethereum, with minimal or little effort, you actually can port them into Avalanche. Now, the underlying technology in Avalanche is very cool. And in my opinion, the most important one is the fact that transactions finalize almost instantly within a second or so. As you know, if you actually send a transaction on Ethereum, it's going to depend on how congested the network is and block times, etc. But in Avalanche, it's extremely quick. The fact that transactions finalizing very quickly means that you can build applications on Avalanche that look and act like the standard real-world centralized applications feel to the end user as well, which I believe is a big benefit of the Avalanche system. All right, let's talk a little bit about efficiency and inclusion of Avalanche. So the underlying software in Avalanche is so elegant and clever that you actually can take an existing laptop or a mini computer like a Raspberry Pi, install the software on it, and become a network participant. This is particularly powerful because it means that the energy needs to be a node within the network is much less, particularly if you use something like a Raspberry Pi. And it also means that people like myself who are hobbyists at home can actually become validators in the network, not only securing and adding value to the network, but also getting the benefits of earning interest on our existing stake. I'm not going to go into technical details in this video, but Avalanche uses a technology called proof of stake, where you stake a certain number of AVAX tokens, and once your validation operations are deemed correct and your period is over, you get a certain percentage of those AVAX tokens paid directly into your wallet, which is different than Bitcoin, which is different than Ethereum. I simply would not be able to become a miner in Bitcoin because I simply don't have that kind of money. All right, next up is governance. Although this aspect of Avalanche has not been implemented yet, because it's discussed, because it's, if you look at the papers, if you look at the documentation that the Avalanche team put forth, it is on the roadmap, and in my opinion, this is one of the key aspects of this system as well. Simply put, once the governance mechanism is available, it will allow token holders, the validators, the community effectively to be able to adjust the transaction fees, adjust the parameters of the system to either increase safety or to increase inclusion of more people, the number of nodes, etc., which I think is particularly important for a growing ecosystem, a growing blockchain to be sustainable in the long term, because as you know, when a blockchain is small, the needs are different than when it's large and widespread. So I think this was worth mentioning as well. So please be on the lookout for the governance mechanism if and when it's available. And we want the community of people within Avalanche to actually take part in this governance mechanism. I most certainly will be putting forth my opinions, and you should do the same as well. All right, let's talk about validation as well. So as I mentioned earlier in the video, Avalanche is a proof of stake system where for you to become a validator, you need to have a certain number of AVAX tokens. You need to put them onto a node that is operating continuously, and you will earn a certain percentage reward at the end of the period which you validate. To become a node operator, you need a few things. Number one, at the time of this video, you need 2,000 AVAX tokens staked into the node. Second, you actually need the node itself. Node basically is a piece of software you can download from the Avalabs webpage, or you can download the source code and build yourself, and it needs to run on compatible hardware. To earn a reward, you need to choose a minimum period of either 2 weeks up to 1 year, and depending on the period you chose, you're going to get a different interest earnings on top of your staked tokens. And to earn rewards, you need a minimum 60% uptime observed by your peers in the network. Now, this is what it takes to become a validator. Believe me, running a node actually is quite simple, and you can really run it on off-the-shelf hardware, whether it's a desktop or a laptop, or you can even run it on a Raspberry Pi, which I have a video for describing all of the steps to do it. Now, there's also a second option. If you don't actually have the 2,000 Avalanche tokens, AVAX tokens required, you can delegate to a node that you know is going to do a good job. For this, you need a minimum of 25 AVAX tokens. And again, you need to choose a period between 2 weeks to a year. And the most important thing is you need to choose a node that is honest and that has good uptime and that is well managed, that you're aware of. Again, delegation is less ideal than validation. The main reason is you don't operate an independent node. If we have more independent nodes in the system becomes more secure. And in effect, I believe it would become more valuable because it would be more decentralized. But again, I understand that not everybody has that option. So delegation is definitely the secondary route that individuals can take. By the way, this brings me to a fine point. As of this video, we have 616 validators in the network, which is more than any other blockchain out there. 616 independent validators that are continuously validating the network. So, in terms of validating or delegating, if you have the option of validation, by all means, you should spend the time, because if you already bought those tokens, in my opinion, that's only going to help you make the network secure, etc. I'd like to touch on this one question that I always received from people that had conversations about this with me. If, people ask me this question, if I have X number of AVAX tokens. Why should I ever bother to validate or delegate? I'm simply going to, hold them and wait for their value to increase, and then I'm going to sell them. Again, I'm not trying to give any kind of investment advice, but there is a simple compound interest math that I can also share with you without speculating about the price at all. So if you assume a person owns 2,000 AVAX tokens, which is the minimum for a validation. And if we, for the sake of argument, assume that the interest rate that the system currently provides does not change in the next 5 years, it sits roughly at 11%. A person that holds the tokens only at the end of 5 years will still have 2,000 AVAX tokens. And a person who actually validates through a node is going to have 3,431 tokens at the end of the 5 years. That is a whopping 1,400 additional tokens you would actually get just by participating and running a simple piece of software. The additional benefit that people often forget about is if and when you run an independent node, you're making the system more secure, and in my opinion, for me, you're making the system more valuable because I can trust the system a little bit more. Again, it's an additional 72% tokens that you end up acquiring just by participating in the system. Again, I'm not talking about the price of the token itself. All I'm saying is the system rewards you for running a node, and right now the reward seems quite generous, and I don't know of any bank account that actually provides this kind of an interest, and I just want to put it out to the people so that you evaluate this as you're, making your own decisions as well. I know I talked a lot. Let me try and summarize some of the points that I made earlier. So first and foremost, Avalanche transactions get finalized near instantly, which make Avalanche very fast. And this is very important from a user experience perspective because people don't like slow things, right? So applications running on the Avalanche blockchain have the potential to look exactly like their centralized hardware counterparts that we all have gotten used to. Avalanche network is very scalable, new nodes can join, and the system itself does not necessarily slow down, which allows the network to reach unprecedented decentralization levels. Right now, as it stands today, Avalanche has the most number of independent nodes that I've ever seen on any other blockchain. The number roughly stands around 616 validators today. And the other important aspect about Avalanche is the economics is very good as well. The system is intended to have a balance between inflationary pressures as well as the deflationary pressures, the transaction fees being offset by the minting rewards that are provided to the validators. Speaking of validators, becoming a validator is quite easy. You can buy off-the-shelf hardware, put the software on it, and you can become a part of the network. There is no massive barriers to become a validator either. The rewards for becoming a validator is quite good. And as I mentioned in the mathematical, reason section, in my opinion, it's quite attractive. Lastly, the last thing that I want to mention as well is existing Ethereum tooling is directly compatible with Avalanche. This, in my opinion, is also a very big thing where if and when people feel more comfortable about the Avalanche technology, blockchain, etc., people can simply bring over their applications from Ethereum or maybe even other blockchains and deploy it directly and get them up and running quite quickly and efficiently. Since I talked about drawbacks for the other systems as well, let me talk about, one drawback that I see for Avalanche. Avalanche is very young, right? The mainnet went live roughly 1 to 2 months ago, and it simply does not have the adoption that the rest of the networks already have. Although it has an amazing marketing team, it already has an amazing community. You can simply join the Discord webpage and talk to the developers directly, etc. I think we need, more time to see how the ecosystem grows. But, from what I understand, the team is already working on quite a good set of applications and good set of features that will make this network, this blockchain, one of the key blockchains to watch in the near future. All right, first of all, thank you very much for watching this far. I really appreciate it. Please leave any comments about what you disagree with, what you agree with, or what you'd like to hear more about in the comments section. And before I leave you, I will create playlists of interesting videos, in my opinion, for Bitcoin, Ethereum, and Avalanche, and I'll be placing them in the information section, as well as you'll be able to access these playlists in my channel. Ultimately, if you like this video, please go ahead and press the like button, and don't forget to subscribe to the channel so that as we create more videos like this, you'll be the first to know. Thank you very much for watching again, and I'll see you guys in the next episode.